line 22, 7B119, Higgs C60 lasers, Analcime Photons, Raman Polarization, Wow Seti. There's a Wow Seti signal. This is the data here, and it won't let me go any smaller. Okay, for some reason it's too big. No, I couldn't get it to get smaller, so we're going to have to hold this up then. So line 22, 7B118, refractive light, Analcime Photons crystal wafer water formula. Googled Analcime Photons and Googled Raman Polarization spectra of the natural zeolite Analcime. So this video talks about C60 lasers, porous molecule, Higgs signals, Analcime crystals and photons, and Raman polarization formulas for dark matter cell structure found in the WOW data line 22. This leads me to my Big Bang theory and how I prove it could happen. Okay, so infrared spectrum, attenuated total reflectance. This is the powder, and these are the diagrams. So let's make them just a bit smaller. Oh, they only go that way. No. And make this one smaller. See if that will make it. No, still won't let me bring it in. I tried everything. So I got this from a blog, and it's called SensIR Durascope on a Nicolet Magna 860 FTIR. Okay, sample powder description. So this is Analcime, and this is a diagram with wave numbers. Okay, and X-min, X-mac, and X-sort it shows. So 1100 to 900 is the Higgs boson signal, ATLAS CERN 2012. It looks the same as that. Okay, that's mine. This one here. Looks like a Higgs signal to me. Everything looks like Higgs signal, right? Okay, and here's another diagram. Signal strengths of the Higgs within Analcime at 16, 27, and 31 are higher to theta comparing intensity. Is this how we add mass to particles? Okay, these three here. Okay. This is the powder cell refinement output. It's a tetragonal crystal. So references are from this blog, rrough.info. I gotta get rid of that bracket there, or else it won't let me post it. Okay, my thoughts. RFUFFID R060023.1. Instrument settings, SensIR Durascope on Nicolet Magna 860 FTIR. So in the Analcime powder data, look at the 1100 to 900, which is this area here. Not sure what it's called. In the first diagram above, it looks like the Higgs signal data. My idea is to see if Analcime crystals are in dark matter particles and if dark matter is porous. Quotes and diagrams are from my blog and other blogs. Okay. So CMS versus ATLAS 2 photon signal plot, February 2012, VIXRA plot. So there's your Higgs signal there at 120 GeVC to 125, I guess. So CMS vs ATLAS Higgs boson signal 2 photon signal plot, VIXRA plot, February 2012. And that was from my blog, alienspace-science-news.wordpress.com. So that's where I blogged it, and it's from another blog, and that information's on the blog post. So I'm going to cross-reference keyword ATLAS Higgs to find a diagram that I'm looking for with the CERN 2012 June results for the Higgs boson signal. I found it on line 22, 7B97, Z69B. Trap RF field effects, C60 beam diffraction electrons ions formula, 5G Wow Seti on the Inland Space Science News WordPress blog. So diagrams that were in that video was this one here showing the possible effects of the trap RF field on the scattered electrons was studied by comparing diffraction data. So there's the different signals for that. Again, there's the blog post for it. Quote from the blog data. Figure 10. The possible effects of the trap RF field on the scattered electrons was studied by comparing different diffraction data produced by an E-beam scattering from a neutral C60 beam passing through the trap center with the RF field on and data obtained with the RF field off. There's a diagram of diffraction from trapped ions. It shows the scattered electrons and Bunsen oven and Faraday cup, E-beam, RF trap, ionization gun, and microchannel plate. And here's electron scattering in molecules. Here's another big diagram with all sorts of calculations on it. Figure 4. Gas phase electron scattering in molecules is composed of A, elastic scattering from individual atoms, B, the interference of waves scattered from atoms separated by distances characteristic of the molecular structure, and C, inelastic scattering characteristics of the molecular electron energy states. The orientationally averaged elastic contributions are expressed above in terms of the atomic scattering amplitudes Fij and the atomic separations Rij and the vibrational mean amplitudes of Ij. The total elastic scattering intensity distribution is shown on the left as a function of S, and the separate contributions of the atomic and molecular scattering are displayed on the right. So that's from www.genetical.com. Okay. Here's the formula from the data. C60 laser electron scattering diagram on the left at 6 intensity looks like Higgs signal, as well from molecular atomic particle data above. The gas phase electron scattering in molecules. Interference of gravitational waves scattered from atoms separated by distances, molecular structure, inelastic scattering characteristic, molecular electron energy states, atomic scattering amplitudes of Fij, plus atomic separations of Rij, vibrational mean amplitudes of I don't know if it's an L or I. Ij in the data is going to continue in the next video. Thanks for watching.